In Part C, the value of an expression, we're going to be talking about how to figure out what the expression, say, 3x minus 1, is worth. What's its value? When the x has a known value. In general, an expression remains generic because we don't know the value of x. But as we progress through our mathematical careers, it will become important to know how to determine the value of an expression for a particular value. This chart can be found on page 127 of your textbook. There are 5 expressions here, and for each one, the variable is given a particular value, and we're asked to find the value of the expression for that value of the variable. The first thing we should do is rewrite the expression so that instead of a variable, there's a blank space where we might write in the value we're given for that variable. Why is this important? Well, it won't always be just one value of x that we might need to try here. In this case it is, but as we progress, we'll learn that sometimes x can be 2, in another case it might be 5, or -2, or 0. It could be anything. For now, we're simply going to replace the x in this expression with a blank space so that we can insert the value we're given, the 2. Once we've done that, we can do the arithmetic. Multiplication before subtraction. 3 times 2 is 6. Don't forget to write down the -1, and then we can do the subtraction. This, of course, equals 5. The value of the expression 3x minus 1 when x is 2 is 5. This is my answer, 5. The value of the expression is 5 when x is 2. For our next expression, we're asked to find the value of -7a plus 4 when a is -3. So let's rewrite the expression with a blank space instead of the variable. The blank space gives us a place to write in the value we're given for a. We're replacing the a with its value. In this case, -3. Again, doing multiplication before addition gives us -7 times -3, which is +21, and then plus 4. All that's left is addition. 21 plus 4 is 25. In the next example, we have 2 places where there's an x that needs to be replaced. Rewrite the expression so that in place of an x, you have a blank space. This used to be 2x minus 3 plus 4x. Now replace the x with the value you are given, -1. Order of operations tells me I must do this multiplication and this multiplication before I can do this subtraction. So this expression is equal to 2 times -1, which is -2, minus 3, because I'm not allowed to do that subtraction yet, plus 4 times -1 is -4. Finally, since these are all addition and subtraction, I can go from left to right. -2 minus 3 is -5, and -5 plus -4 is -9. Example D is similar to example C. Take 2x minus 5 minus 8x and rewrite it as 2 blank minus 5 minus 8 blank, and then replace the x with a 5. Multiplication before addition or subtraction tells me I must do 2 times 5, minus 5 minus 8 times 5 is 40. I did this multiplication and this multiplication and simply wrote down the minus 5 minus in between. 10 minus 5 is 5, and 5 minus 40 is negative 35. In our last example, we have y squared minus 6y plus 9. When I replace y with 4, my expression looks like this. Now the order of operations says I must do multiplication before I do addition and subtraction. But if you'll recall, we have to do exponents even before that. We're going to be talking about exponents in a lot more detail later on in the course. For now, just recall that 4 to the power of 2 just means 4 times itself 2 times. So this piece right here means 4 times 4. And I must do this before I do multiplication or addition or subtraction. So 4 squared is 16 minus 6 times 4 is 24 plus 9. Now all I have left is addition and subtraction. So going from left to right, I get 16 minus 24 plus 9. Let's take a look at another example. Here's a question that asks you to find the value of the expression negative 11 minus 3x plus 2 times x plus y when x equals negative 3 and y equals 1/2. What's different about this problem is that there's more than one letter involved. We can proceed as we did before. I'll rewrite the problem, but instead of an x, I'll put a blank space. Instead of an x and instead of a y, I'll put a blank space. Then I can go back in and fill in every place that I saw an x with a negative 3. And everywhere that I saw y with a 1/2. Having made my replacements, it's down to me to make sure that I do the order of operations correctly. Parentheses first. Here I have parentheses with arithmetic inside them that I can do. Negative 3 plus 1/2 is negative 2.5. But if I want to write this as a top-heavy fraction, then I need to think about how many halves I have when I get to this place. Here's negative 1/2, negative 2 halves, negative 3 halves, negative 4 halves. This is negative 5 halves. So I can replace negative 3 plus 1/2 with negative 5 halves. But the rest of the problem needs to be written down and those operations performed in turn. What I have now is a subtraction, a multiplication, an addition, a multiplication. So I'll do the multiplication before I do the addition and subtraction. This multiplication, I've used this minus sign, so I'm only multiplying 3 times negative 3. 3 times negative 3 is negative 9. Plus, I've used this plus sign, so I'm only multiplying 2 times negative 5 halves. I could use the commutative property of multiplication to reverse these two numbers. Then I'd be thinking 5 halves times 2 means 5 halves of 2. 5 halves of 2 is 5 times as much as 1 half of 2. Since 1 half of 2 is 1, 5 times that is 5. This is a positive times a negative, so this needs to be a negative 5. Of course, the other way you could think to do this problem would be simply to rewrite the 2 as 2 over 1, and since we're multiplying, cancel the 2's. 1 times negative 5 is negative 5 over 1 times 1 is 1. Now all I have left in my problem is addition and subtraction. I can either simplify this opposite of a negative and make that a plus, and plus a negative and make that a minus, or I can just think very carefully about what it is I'm really adding. Negative 11 minus negative 9. Minus negative means plus. The opposite of a negative is a positive. So this is negative 11 plus 9. Negative 11 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 is negative 2. Negative 2 plus negative 5 means negative 2 minus 5. Negative 2 minus 5 is negative 7. I'll do some more examples with more than one variable when I do the worked examples for this section.